All right, today we're going to tackle a massive challenge in the world of engineering. But here's the twist. It has absolutely nothing to do with building materials or complex mechanics. Nope. The problem is how we build the engineers themselves.
I mean, just think about that for a second. We spend so much time and energy focusing on the what, the incredible bridges, circuits, and software engineers create. But we kind of forget to ask how. How do we actually create the skilled, adaptable people we need for the future? That's the big question we're digging into today.
And this isn't just some academic question either. This has serious, real-world consequences. To really see what's at stake, we're going to look at a case study from South Africa's vocational training system, where a major breakdown is putting the whole pipeline of new talent under some serious strain. And we're not talking about a minor delay here. This is a massive logjam. You've got thousands of eager, skilled students who've done all the work, they've completed their training, but they're just stuck in limbo, unable to get certified and actually get out into the workforce. The human cost for them is huge, and for the country, it's a massive economic hit. So what's actually causing this giant bottleneck? Well, it's pretty much a perfect storm of system failures. First, there are these huge backlogs in getting the end diploma certifications processed. Then, you've got data mismatches in the National Records database, which just creates a bureaucratic nightmare. And, maybe most importantly, there's this growing gap between what students are taught in a classroom and what they actually need on the job, all because the curriculum just can't keep up. So how in the world do you solve a problem this complex? You don't just patch it up with tape, you have to re-engineer it from the ground up. And this brings us to a really powerful idea. Taking the principles of engineering itself and applying them directly to education. It's called curriculum engineering. Okay, so what does that actually mean? Well, at its heart, curriculum engineering is about treating an education program like you would any other engineering project. It demands a systematic design, really precise implementation, and constant evaluation. And the goals? They're simple but totally transformative. You want to make the curriculum auditable so you can actually track progress and compliance, you align it directly with real-world careers, and you make sure it works seamlessly with national standards. No more guesswork, just solid engineering.
And just like a civil engineer has blueprints and a software engineer has code, a curriculum engineer has their own set of specialized tools. These are tools designed specifically to bring order, logic, and traceability to the whole process of building a learning path.
This new approach really leans on two core tools. First, you've got logograms. Think of these like visual flowcharts for education. They map out every single decision point and compliance step, making the entire system transparent from start to finish. Then you have algorithms. These are more like recipes, step-by-step instructions for everything from planning a lesson to assessing a career path. Together, they make the whole process repeatable, predictable, and way more reliable.
And let's be really clear about this. This is not just a new set of buzzwords. This is a complete paradigm shift. It's about moving away from this old, static, theory-based model to a dynamic system that's built from the ground up to produce graduates with skills that are ready for the future.
This slide is just a brilliant illustration of that shift.
Okay, so in traditional electrical engineering, you'd use calculus, that integral right there, to calculate the energy in a circuit. That's still fundamental stuff. But the AI-enhanced engineer, well, they take it a step further. They use AI to analyze and optimize that power in real time, which lets them do incredible things like predictive maintenance. The key point is, the new method doesn't replace the old one. It builds on top of it, creating a much more powerful and relevant skill set.
So, when you apply this engineered approach to education, what kind of professional do you actually get? Well, you get a whole new breed of technician, someone who is specifically designed for the demands of what we call Industry 4.0, that modern, connected, automated world.
The goal here is nothing short of a complete transformation. It's about taking the solid, foundational skills of a traditional artisan and layering on the digital, analytical, and AI-driven skills of a modern technical specialist. It's all about creating a hybrid professional.
And this hybrid model shows you exactly how it works. You take a traditional skill, like, say, manual fault finding, and you enhance it with machine learning. The result? A specialist who can do predictive maintenance. Or you take basic circuit design, you combine it with generative AI and Python, and suddenly you get automated system optimization. This is how you directly fix that skills gap we talked about, by explicitly designing a curriculum that fuses old school knowledge with new school tools to get a tangible, high-value result. Now, this isn't just a collection of good ideas thrown together. It's a complete integrated system. This new blueprint for learning is built on a whole series of strategic pillars that make sure the entire process, from day one to graduation, is coherent and effective. This whole framework really rests on 6 interconnected pillars. It all starts with super meticulous curriculum design. It requires a formal partner accord with industry, so everyone's on the same page. It uses diagnostics for learner readiness, and it maps all the training directly to job outcomes. And this is all supported by a modern systems architecture and sped up using AI to streamline documentation while always keeping humans in a loop. It's a truly holistic plan. So why does this all matter so much? Because the advantages are real, they're concrete, and they directly solve the problems we started with. This framework creates traceability, so students don't get lost in the system anymore. It directly increases their chances of getting a good job. It resolves those awful certification delays. And it finally bridges that stubborn gap between a piece of paper and real-world competence. As Chishingombe Chitati Fiston, whose work at the Sayabono Discovery Center is really the basis for this whole model, concludes, the ultimate purpose is to strengthen the most important connection of all, the path from the classroom to a meaningful career. So, we have to ask ourselves, as technology re-engineers literally every aspect of our world, from our power grids to our supply chains, are we applying that same innovative, systematic, and ambitious thinking to the systems that are supposed to build our future? Is our education system truly ready for what's coming next?